We're going to look at a plot of infections versus time. And first of all, we have a plot here of total infections. We have an S-curve. We could have had a population of 30, and we reached total infection after 10 days. We end up with an S-curve. It could be logistic or something related to that. We're going to produce a plot of new infections versus time. In the early days of COVID last spring, there were a lot of these graphs on the news, and this will explain partially at least what they were talking about. Well, in this case, we have a time equals 0, we have 1 infection, time equals 1, 2 infections, time equals 2, 4, 7, 11, 15, 19, 23, 26, 28, and 30. Those are the total number of infections. We can just copy that into our chart. 1, 2, and let's see, 4, and then 7, and then 11, 15, 19, 23, 26, 28, and then 30. And we're going to start here at 0, and then the new infections and going from 1 to 2 are going to be 1, and then going from 2 to 4 are going to be 2, 4 to 7 are 3, 7 to 11 is 4, 11 to 15 is 4, and 15 to 19 is 4, 19 to 23 is 4, and then we have 3, and then 2, and then 2. Okay, we can superimpose a plot onto here, and so we're going to start at 0, and then we have 1 new infection right here, and so at day equals 1 we have 1, and then day equals 2 we have 2. Move up a little bit. And then day equals 3, we have 3. Day equals 3, up a little bit, 3. And then day equals 4, we have 4. Day equals 5, we have 4. It kind of levels off. Day equals 6, we have 4. Day equals 7, we have 4. Day equals 8, we have back to 3. And then day equals 9, we have 2 and 2. So you can connect the dots here, and it should look like a bell curve. So, okay, that's pretty much all there is for that section.